Okay, in this video we will be talking about lesson C-3, which is titled Properties of Chords. So basically we'll be talking about chords today and their different properties and what we can do with them, okay? So we have three properties of chords we'll be dealing with. We'll be dealing with perpendicular chords, congruent chords, and then intersecting chords. First off, perpendicular chords. So if we have a diameter or a radius, if a diameter or radius is perpendicular to a chord, then this diameter or radius, it bisects the chord and its arc, meaning it splits it directly down the middle, directly in half. Okay, so for our example here, we'll look at the top half right here. We'll say if this radius EH, if this is perpendicular to chord AB, then we know that the chord is being bisected at point F. So we'll say that AF is equal to FB, and we'll say that the measure of arc AH is equal to the measure of arc BH. So basically we just split that arc into two separate measures, and then we also know that these chord is being split as well. So find CG, again, if CD is equal to 12.4. So we see that EI is perpendicular to CD, so we know it's being split in half. So CG will just be half of 12.4, which is going to be 6.1. Okay, that's kind of what you'll be seeing with this stuff. All right, congruent chords. If two chords are congruent, then one, they are equidistant from the center. What that means, what that will look like in problems you might see, you'll see that as the little segments you draw from the center to the chord, those would be congruent like that. So EF and FG would be congruent. Also, their corresponding blanks are blank, so their corresponding arcs are congruent. Alright, so if we have that chord AB is congruent to chord CD, then first we know that, like you said, those segments that are formed from the center to the chord, those will be the same length, or EF is equal to EG. Also, we'll know that the measure of arc AB is equal to the measure of arc CD, because the chords are congruent. So those corresponding chords are congruent, and then if those corresponding arcs are congruent if the chords are congruent, and then we know that they're equidistant from the center. So, our example, we're given that AB is 7, okay, EF is 3, DG is 3.5, and the measure of arc AB is 49 degrees. Find the measure of EG. So, since EG and EF are going to be the same, so this also has to be 3. And the measure of arc CD is going to be the same as the measure of arc AB, so 49 degrees. Awesome. Now, moving on. Intersecting chords. So we have a special relationship between chords that intersect. When two chords intersect each other inside a circle, the products of their segments are equal. So we have chords AB, and CD that are intersecting each other at point X. So what we have is that we have relationships now. When I split my two chords, okay, I know that this part times this part is going to be equal to the product of the two parts of the new segments of the other chords. So in essence, this is going to tell me AX, the length of segment AX times the length of segment BX will be equal to the length of segment CX times length of segment DX. So let's look at an example. I knew CX was 18. DX was 6.5. BX is 9. And then we want to find AX. Let's call it X. Okay? So let's multiply what we know. We're going to do the 9 times the X right here equals 18 times 6.5. Alright, calculator time. 18 times 6.5. Sorry, just give me a second. Alright, so 18 times 6.5 is 117. So 9x is equal to 117. So divide both sides by 9. X is equal to 19. So that tells me that AX is 19. And boom. That's how those are solved. Alright, so let's look at some problems, some algebra problems right here. Find X. Okay, so we've got two chords that are congruent. What do we know about congruent chords? We know that they're equidistant from the center and their arcs are congruent. So we have expressions for their arcs. So since the chords are congruent, the arcs are congruent. So this will be set up as follows. Seven x plus 24 equals 115. Subtract 24 from both sides. So 7x is equal to 91. So x is equal to 13. Again. Number 2. This time we're given stuff for the chords. We know their arcs are congruent, so that tells me the chords have to be congruent. So 15x or 18x minus 2 is equal to 52. So 18x is equal to 54. So then we divide both sides by 18 to give me that x is equal to 3. Awesome. Number 3. Alright, so here we have one just kind of like this one. So we're going to multiply the two parts of the chords together. So these two of the same chord will be x times x, which is x squared. That equals 49 times 4. So 49 times 4 is 196. So to get rid of that square, we have to take the square root of both sides. So x is equal to 14. The next one, we're going to be dealing with, you have to draw a picture first. So let's draw a circle. Okay, the diameter of a circle with center P bisects some chord AB at point X. Okay, so let's draw some chord AB. We're going to draw this diameter so that it bisects this. Okay, since it's bisecting it, it's going to be perpendicular. Points A and B. What type of triangle is the triangle formed by points A? And this is going to be point X right here, excuse me. What type of triangle is the triangle formed by point A, X, and P? So let's draw a third side of the triangle. That has to be a right triangle. So this is probably going to be used to solve for some stuff because we know how to solve right triangles from Pythagorean theorem. So if AB is 8, okay, the whole thing is 8. EF is 3. Find EB. So this is what we're finding. Okay. We know the whole thing right here is 8, but since this EH is perpendicular to AB, we know it's also bisecting it. So this little side right here has to be 4. So let's find EB. Call it X. All right. Pythagorean theorem. We know two sides of a right triangle. We can find the third by using Pythagorean theorem. So x squared equals 3 squared plus 4 squared. Okay. X squared is equal to 9 plus 16. So that's equal to 25. And you do the square root of both sides, you get x is equal to 5. So that means EB is equal to 5. Yay. Number 6. The distance between a 16-foot chord and the center of a circle is 15 foot. Find the diameter of a circle. First step, draw a circle. Okay, drew a circle. We know we have a 16-foot chord. Okay, so draw some chord. Okay, and then we draw the center of the circle. So we know the distance between the center of the circle and the chord is 15 foot. So that distance has to be a perpendicular distance. That's the shortest distance between a center and the chord. Oh God, that's terrible. Let's try that again. Okay, pretend that's a radius, good enough. And then we'll go all the way across to get a diameter, okay? Boom. So, I know that this, let's see, this distance from here to here is 15. Okay. And then let's see, I don't actually need this. Then I also know that the whole entire chord is 16. So, if I'm trying to find a diameter, let's find a radius first, and then we can find the diameter from there. I can draw with this little tablet thing I have is weird. So, alright, I know this is a right angle. Okay, since this is perpendicular, this is going to be bisected, so this side will be 8. Let's find the radius. Okay, so r squared is just equal to 8 squared plus 15 squared, which will be equal to, let's see, solving that using Pythagorean theorem, blah, 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 you're going to end up getting that r is equal to 17. Okay, we know how to solve those using Pythagorean theorem. Okay, so now that r is equal to 17, your diameter is just twice that, so it's 34. Awesome. Moving on to the back now. Alright, which of the following statements is not true? If a radius is perpendicular to a chord, it bisects the chord. That's true. If two chords are perpendicular, one of them must bisect each other. Okay, I don't know about that one, okay? I can have probably two chords that are perpendicular that might not bisect each other, so maybe. Or let's just look at it, draw it out. Try to draw two chords that are perpendicular but don't bisect each other. How about those two chords? They're perpendicular, but do they bisect each other? Nope, neither of them do. So, they don't have to bisect each other, so that's false. Which part of a circle is considered to be the longest chord? Okay, the longest chord you can ever draw in a circle will be the diameter. Awesome. Okay. We have a typo here. This one, for number, we're just going to, so number 9. In the diagram, chords PQ and RS intersect at point T. This is going to have to be TQ instead, not PQ. So, let's look at this. If PT is 8, TQ is 3, RT is 6, let's find ST. So, we're going to multiply RT times ST, so 6 ST will equal to PT times TQ. So, 8 times 3 is 24. Divide both sides by 6. ST is equal to 4. So next, PQ. Okay, PQ now we're given the whole thing to be 12, and TQ is 2. Okay, so PQ now is 12. TQ is 2. So PQ, the whole thing is 12. If TQ is 2 and the whole thing is 12, this PT has to be 10. All right. And then if RT is 5, find ST. So RT times ST gives me 5 ST. That equals 10 times 2, which is 20. So divide both sides by 5, you get that ST is equal to 4. Awesome. Now this one, now we're just dealing with everything in terms of letters, but it's still the same method to solve this. If PT is M, TQ is N, ST is P. Find RT in terms of MN and P. Okay, so we'll just plug in what we know. P times whatever RT is equals, so it's going to be PT times TQ, which is M times N, so MM. Now to get RT by itself, I need to divide both sides by P. So I can't really simplify that on the right side, so we just have RT is equal to MN times over P. And that's our answer. It's in terms of MN and P like I wanted. Alright, lastly, 9D. If RT equals ST equals 5 square roots of 2. So let's draw on here 5 square roots of 2. Okay. 5 square root of 2. 5 square root of 2. And then PT equals 2 times QT. So 2 QT. Then I'm just going to leave this as QT. We want to find PQ. Alright, so 2 QT times QT is going to give me 2 QT squared. Because QT times QT is QT squared, then that 2 is still out there. That equals 5 square roots of 2 times 5 square roots of 2. So when I'm solving this one, I'm going to multiply the 5s separately, because you multiply the things outside the square root, then you multiply the things inside the square root separately as well. Okay, so this will be still 2 QT squared. So 5 times 5 is 25. Then square root of 2 times square root of 2 is just 2. Right? So I'm going to leave that times 2 like that. I'm not going to simplify it yet, because I'm just dividing both sides by 2. So those 2's will cancel, leaving with 25 here. Take the square root of both sides. QT is equal to 5. So for PQ now, PQ is just, let's see. If QT is 5, that means PT is 10. And then PQ is just these two added together. So PQ is equal to 15. Boom. Moving on. Almost finished. Number 10. Find X. So let's see. These two are congruent arcs, right? So what I'm going to do is I'm going to find this arc. Since they're congruent arcs, I know that this arc xy plus zy, I just know for sure this arc xy plus zy is going to be whatever the arc 360 minus 76 is, which is